pi times radius, so 3.14 times 5 times 5, 25 times 3, whatever, 76 point something or 75 point something. So whatever that answer comes, as soon as this return comes, this will be replaced by whatever that number is. Okay? And then that number will get stored over here. Everybody agrees?
Yes.
So how many lines of code we needed to call this function? 2 lines of code, right? However, if you take a look at this function, you will notice it's totally self-contained, meaning this function does not use any data inside the class. Okay, so let's pretend even if I declare something double, let's say d1 equal to 2.3. Okay, so I could have variables declared over here, but is the code in this function using this variable?
No.
No, so it's totally self-contained. To call this function, we do not need any memory inside the object, right? Okay, so to make our life easier for those cases where the function does not use any data inside the class, we have the static keyword, okay? So in this case, what we will do is we will add an extra keyword over here called static, okay? So the minute we add static over here, we do not need, this is not the way we will call the function, so this will not work, okay? Because it's static, meaning totally self-contained, our code will now, calling code will look like this. Radius equal to, so name of the class, which is my compute, dot, name of the function, which is compute area, and then whatever parameter you wanted to pass it. So you can see now we only need 1 line of code to call the function, which previously we needed 2, okay? So once again, anytime you write a function inside a class which does not rely on whatever variables you have declared inside the class, mark it as static. This way the caller can call it in 1 line of code rather than having to create an object of the class, okay? So that's the benefit of the static method. So it makes calling code. So static is always applied to a function. Sorry, it can be applied to a function or a variable, applied to a function or a variable inside a class. Okay, I haven't discussed the variable static yet. So anyway, if you mark the function as static, it makes the calling code basically single line. And once again, it will go as name of class dot name of function. So that's the syntax for a static function. Okay, so now let's modify things a little bit. What if I did this? I marked it static, right? But instead of putting pi over here, okay, suppose I also had one more function over here, public static double compute volume, okay, double radius, okay, and suppose I said, so again double pi equal to 3.1415 and return 4 divided by 3.0 multiplied by pi multiplied by radius multiplied by radius. Remember, it's 4 over 3 pi r cubed, correct, is the volume. So now we have 2 functions inside the class. Both are marked static. Okay, so first let's check this. Is it legal or is it okay to mark this second function static?
Yeah.
What's the requirement for a static function? That the function should be totally self-contained. The code over here should not
No, it's not.
use any data declared inside the class.
No, it's not allowed.
So is it totally self-contained?
No.
To call this function, do we have to go use any of the data declared in the class?
No.
No, so static should be okay, right? Because it's static, how will somebody call it? Name of the class dot name of the function. So what's the name of the class? MyCompute dot, what's the name of the function? Compute volume. Suppose somebody wanted to call it with a radius of 3.0, and because it returns a double, so now we can store the result something like this, double volume. So one line of code will end up successfully calling this function. Everybody agrees?
Yes.
Okay. Now, see, whenever we write code, there's a concept called refactoring. Okay? All good programmers will write some code, then they will refactor it later. Refactoring basically means to organize it so that we are cleaner, writing it less lines of code. So as soon as you develop this function, then a few days later you added this function, you'll realize you're repeating a few things. Okay, what are we repeating over here?
Pi.
Pi. Okay, so what you will do is you will say, oh, you know, why should we declare here again, declare here again? So let's do this. Let's move this double pi and make it the variable inside the class. Okay, so as soon as we do this, then of course we won't write this line, we won't write this line, because this pi now will come from here.
It will static.
So now will the static keyword make sense over here?
No.
Now see, this pi over here is using the data declared inside the class. So this code will not even compile. You try to run it, it will give you a compiler error that it is using, that this is a non-static field. So this is the error you will get, that your static method is using a non-static field called pi. Okay. So this is where, as I mentioned, the static keyword can be applied to a function, or it can also be applied to a variable. So in this case, what we'll do is, because the value of pi does not change no matter how many objects of MyCompute we create, whether we create one object or 100 objects, value of pi will always be the same, right? So now what we'll do is, we'll go over here and further add the keyword static to the variable. So once we add the keyword static to a variable, think of it this way, that all objects of this class will share this variable. Meaning there will be a single memory for no matter how many objects of MyCompute you create, there will be one single memory for this particular variable. So if you have 5 objects of it, all 5 of them will be pointing to the same memory for this variable pi because it's marked static. Okay? So now it is okay to use a static variable inside a static function. Okay, so it is okay to use static variable inside a static function. Okay, so now this is okay. This is also okay, and the code is a lot better because we're not repeating this declaration of the pi in each and every function, right? So everybody follows the static keyword. Okay. So anyway, as I go to the computer, maybe not this lecture, but next lecture, I will give you a few more examples so that you completely understand when to use static, when not to use static. Okay. So now let's come to the next three keywords, which are extremely important for us to understand. Once you understand when you will use abstract, when will you use virtual, when will you use override, then the understanding of the basic object-oriented programming will become a lot easier. Okay?
So this is called refactoring, but what you just did.
I refactored the pi to appear as a single data inside the class so that we don't have to repeat these two lines. So these two lines will disappear, and that's called refactoring. Okay, now let's go take a look at these three concepts. They are a little bit harder, so pay special attention. Because once you understand those three concepts, the rest of our learning of basic object-oriented programming will be extremely easy. And I'll give you a warning, even some of the really good developers often do not know what's the difference between these three things, okay? So even if you have been programming for a while, take a look at my explanation and hopefully you'll be able to understand it clearly, what do these mean, okay? Okay, so anyway, so now we want to clarify virtual, abstract, and override. Okay, all of these have to do with inheritance. Okay, so in fact, actually, this will be a lot better if I went to the computer. So let me go to the computer, and because then I can copy and paste the code and save a lot of time. So in a minute, once the okay, so hopefully you guys have all obtained Visual Studio. And once again, you know, unless you've been programming for a while and you think whatever we have covered so far is too basic, if you are, let's say, not as confident in your programming, whatever I create in the class, make sure you go home, open the computer, and try to recreate it. That only then you will become better at programming. So